This is an example of a OneDiff backup made to a local data store. OneDiff is also able to back up to a remote folder hosted on a remote IP tunneled through SSH. The only requisite is that you have a remote SSH server that is reachable at some port. For our case, we are using a small Linux CentOS virtual machine which has multiple disks. First round of a OneDiff scheme consists on a full backup. Subsequent rounds only send differential data. For this example, we have chosen an NFS datastore, which is not BMFS formatted. That will place some drawbacks at the time to check data and will also break the sparseness of your hard disks. So if you are using thin disks, you should always back up to a BMFS formatted volume. Well, now the first phase of this OneDiff backup is finishing, and we'll go next to see what will happen on subsequent cycles. And this is the second round of this OneDiff backup scheme. From now on, only the differential data will be copied from server A to server B. Once the differential data has been sent from server A to server B, it is coalesced with pre-existing data at server B, which has in turn been created by the previous OneDiff cycles. From the second round and on, OneDiff uses what we call trivial check, which is a compounded set of checks that reinforce the absence of an in-out error from part of the copying binaries. It consists in calculating the checksum of the first 500 megabytes by default plus the bytes in use. As we exposed before, we are using an NFS volume to illustrate some of the drawbacks that you may encounter when using this type of data store. As NFS volumes may not preserve sparseness on your virtual hard disks, the part of trivial check that compares bytes used in the sparse file is useless. Still, it makes sense to compare checksums in the first chunks of the VMDK disk, especially in Linux systems, as the first superblock will be somewhere there, and any change in the data structure of the whole disk will trigger a change here.